Hi there viewers, welcome back to this channel. In this video, we are going to be talking about lipid peroxidation or oxidative rancidity. That is the second name or the common name you might have heard about, that is rancidity. Now you should know that rancidity occurs with substances that have fatty acids or generally called fats and oils. So oily foods or any food that contain fatty acids, they are susceptible to spoilage known as rancidity. So, and with fish being our point of view, I mean our case study in this case is going to be um, the fact that fish can also deteriorate by oxidative rancidity. And we want to go through how fish being an oily product, a product that contains fatty acids, how as a product that contains fatty acid, how it can undergo rancidity. So generally, fish contain there are two types of fatty acids, which are saturated fatty acids, saturated and unsaturated fatty acids. So, and fish contain these fatty acids. So we have um, fatty acids. So the kind of fatty acids you find are the myristic acid. We have the myristic fatty acid, myristic. We have the steric fatty acid. We also have the palmitic. All right, so have the palmitic fatty acids. So these are available in fish. And then the unsaturated fatty acids. We have the monounsaturated and the polyunsaturated. So the monounsaturated, let's just say the monounsaturated and the polyunsaturated. For the monounsaturated, we have this common uh, arachidonic acid, arachidonic, and oleic acid. We have oleic acid. We have the palmitoleic. So, but for the um, excuse me, this is arachidonic acid is actually, yeah, it's an unsaturated acid, fatty acid. I think it is monounsaturated. So, but for the PUFAs, we have, so the PUFAs are the polyunsaturated fatty acid, and these are very, very healthy. So these are what we say are good for our health, because they are they 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 are polyunsaturated, meaning that they contain many double bonds. Is that okay? So, and they are good for our health, unlike the saturated fatty acids. So since fish is highly abundant, fish contain more PUFAs than it does contain monounsaturated. So for the PUFAs, we have the eicosapentaenoic acid and all those higher docohexanoic. So all of those higher fatty acids, those are what make up the polyunsaturated fatty acids. Okay, so now in the context of the polyunsaturated fatty acids, how did they get um, um, how do they become peroxidized? Or you say, how do they become rancid? How does that PUFA, how does a PUFA standing for polyunsaturated fatty acid, so how does it get um, rancid? How does it go bad? All right. So a particular fatty acid, for a particular fatty acid, so generally they go rancid in the same way, but now we are generally talking about unsaturated fatty acids. So you know that a fatty acid basically has a glycerol backbone and a, a glycerol backbone. That's for a triglyceride. So you have three fatty acids and a glycerol backbone. But what I want to do now is just isolate the fatty acid. So if we isolate the fatty acid, we're gonna have C double bond O OH. So, and then that is bonded to this with a methyl, and then we have this bonded to R, right? So this is what we have here for our molecule of a fatty acid, any molecule of fatty acid. So now our main focus now is on this carbon here. Now this carbon is what we call a methyl bridge. A methyl bridge is when you have CH2 in between two double bonds. So when two double bonds are, surrounding a CH2, that is a methyl group. Now one thing that is very peculiar to this thing, this methyl bridge, is that it is acidic. And we're going to get into understanding what that means in a jiffy. But first, we should know that the lipid peroxidation or oxidative rancidity takes place by what we call a free radical mechanism. A free radical mechanism. So, and if you know what a free radical mechanism is, it means that we are going to have an intermediate stage that will form a free radical. And free radicals are very, very reactive, highly reactive. So there is going to be an intermediate step where we will form a free radical, which is very reactive, all right? So, and the entire process takes place in 3 steps. We have the initiation step, we have the initiation, and we have the propagation, and we have the termination. So it's basically simple. In the initiation step, the reagent approaches, and then in the propagation step, a free radical is produced, and that free radical joins with another free radical, and then termination occurs. Right. So that's just the basis of what happens in all of these 3 steps. So how do we start in the initiation step? So in the environment where this guy is going to be oxidized, the first thing that happens is that usually it could be a water molecule mine. So water in that fish, in the fish body, is going to attack. Remember I said this is called a methyl group, a methyl bridge. So what happens is that water molecule is, which consists of OH group, is going to attack this. So this guy is going to be deprotonated. So this guy, guess what? Deprotonated. Protonated. So, and what does that mean? It means that this H group is going to be attached to this OH, and then what happens is that what? Water is formed here, and then this guy becomes a carbanion. A carbanion means a carbanion means a carbon atom with a negative charge, an anionic carbon. Is that okay? So, now how does that form? Now, what will form when this happens is that when there's an abstraction of this proton, is that we're going to have something like this. So notice here that there is now, so these are carbanion. Notice here that there is now a what? A negative charge. There's a negative charge being formed there. Now this negative charge, how is this stable? How is this negative charge even possible? First, why is this methyl? These are hydrogens. These hydrogens, I told you they are acidic, right? They are acidic. What does that mean? It means that they are liable to be given off, isn't it? Because Arrhenius define acid as what? As the only positive, as the substance that produces hydrogen ion as the only positive ion when dissolved in water. So they become acidic. It means they are able to be given off. And the deprotonation is according to Brunselauer that said that what is the substance that protonates some other another reagent, another substance. So this guy protonates another reagent. And why is he able to do so? Now this is essentially why he's able to do so. I'm going to link a video in the description that explains what I want to talk about now, which is one of the videos I made. Now, why this guy is able to be deprotonated, or why it is acidic or the acidic tendency means that it is capable of being deprotonated. Is that okay? So why is the acidity possible? That acidity imbued on it. That acidity is possible because of these two double bonds and the influence they have on that carbon. The influence they have is called the inductive effect. The inductive effect. And in this case, it is called the negative inductive effect or negative I group. You see, double bonds are negative I group. Why? Because they reduce the electron density in our molecule. So what does that mean? It means that they draw more electrons towards themselves. If you know, if you understand what this double bond are, essentially, you know that double bonds are basically formed by, we have a sigma bond and a pi bond, and in the pi bond, the pi electrons are only lateral overlaps, which are not necessarily filled by paired electrons, which are not necessarily filled by paired electrons. The electrons in that shell. That shell is unhybridized. So because it's unhybridized, it is only overlap. The two shells are only overlapping. So because they are merely overlapping, there is an electron. There is a sort of electron deficiency. So there's a sort of electron deficiency. Let me see, change the light. Okay. So there's a sort of electron deficiency. So because of that electron deficiency, electron density is likely or is going to actually move towards the double bond. So and because of that, this hydrogen, so the electronegativity value of this carbon has increased. So meaning that it is more electronegative than the normal carbon. Carbon normally has electronegativity value of about 2.1 to 2.4 thereabout. So it's going to be higher than that. Why? Because these guys are negative I groups and they're going to draw electron density to themselves. And because of that, there will be unequal sharing of the electrons between hydrogen and carbon. So because of that, these hydrogen are capable of what? Of being lost. I hope that is clear. And that is essentially what is even going to make this carbanion possible, because a carbanion is naturally very reactive as it is, but is able to stay here. Why? Because of inductive effect also. Why? Because this negative charge means that it has many electrons. It means electron is abundant, isn't it? So it's going to draw electron density to itself. Because of that, this carbon does not feel the weight of this electron that is on it. Because these are two electrons here. Now, so that is that about this case. Now, what happens is this. So this is what happens in the initiation step. Now in the propagation step, here now comes our oxidizing agent. So oxygen from our oxidizing agent is going to now come and attack this guy. So this guy is going to be attacked by oxygen. So which is the action of this, the major action of the oxidation. So when this oxygen attacks it, what will form essentially is that we have something like this. Okay, so what we have is this, that this guy, oxygen that oxidizes it is going to come here, and then you have something like this, something that looks like this. So notice again here that there is going to be a negative charge on this oxygen, a negative charge on this oxygen. Why? Because it is not attached to another substance. You know, surrounding oxygen will have two bonds because the electron of oxygen is two. So it is only one bond here. It means it's sharing only one electron with this guy. So because it's sharing one electron with this guy, it's going to have one more electron that is unpaired. So because of that, this guy is going to be very reactive, and this is what you call a lipid peroxide radical. So, and this is essentially why it's called lipid peroxidation, because a lipid peroxide radical is formed. So this is the intermediate step I was talking about. So this intermediate step is what gives rise is what happens in the propagation step, and is what gives rise to lipid peroxidation. All right. So these are lipids and fatty acid. So it has been this lipid peroxide radical that is formed. I said it takes place via what? By what? A free radical mechanism. So these, and for free radicals, they are highly reactive. So because of the very high reactivity of this guy, is going to, so we can shorten this guy to what? ROO minus. So RO minus is going to now find another RO minus because they are going to be oxidized in parts, so differently. So different molecules will be oxidized in parts, and then it's going to find another RO minus. So they react together and form what? R. So they form ROOR, which is basically our lipid peroxide now. This is what you now call lipid peroxide. Lipid peroxide. So plus O2. So this is what you form when both of them react together. And then, so this guy is going to, so the propagation step is where many of these radicals are formed, and then then the termination step is where the lipid peroxide radicals are now coming together, and then they form lipid peroxyl radical form lipid peroxide. So that is what takes place in oxidative rancidity. So what might now happen at the end of the day is that the fouling of that fish actually occurs when there is accumulation of this, or sometimes, in fact, when the lipid peroxide is formed, a polymerization might occur. So many lipid peroxide are going to polymerize and form very larger molecules that essentially affect the quality of the fish, and makes it have foul smell, bad texture, and the rest of that. So those are things that happen. Now, this lipid peroxide could also break down. Now, what it will break down to depends on the site of oxidation as well. So, but technically, usually the methyl bridge is where oxidation takes place, and the possibility of forming aldehyde, ketone, or alcohol is dependent on where the oxidation actually takes place. All right. So, and those are some of the products of this this oxidative rancidity at the end of the day, right? So now, how do you now prevent oxidative rancidity from taking place? How do you prevent oxidative rancidity from taking place? So prevention is the first thing you do is this: you make sure that the that you prevent air. You prevent air. So how do you prevent air? You make sure that you either keep it keep your fish in a cool, dry place in the absence of air, or you put in the refrigerator or in the freezer for freezing, or you smoke. Now, when you smoke or you put in a dry environment, it helps the it helps to prevent the oxidation of the puffer. Is that okay? Now, another thing is that you prevent catalyst, prevent catalyst that might oxidize this thing, oxidize the fish material. Is that okay? So you prevent catalyst. Another thing is you can also prevent elevated temperatures. Elevated temperature could also, really the possibility of increase the possibility of being oxidized. Or you use antioxidants to prevent oxidizing agents. So antioxidants to prevent oxidizing agents. So oxidizing agents could also lead to the oxidation of this thing and make your fish product go rancid. All right. Now, one way in which by which in the making of fish silage, or even in fish canning, they use this technology also to prevent the fish from being oxidized, the fish oil from being oxidized. Um, um, 0.1% or to 0.2% of tocopherol or BHA or BHT are added. All right. So that is in the fish processing industry. They add 0.1 to 0.2% of these guys to make sure these are antioxidants. Tocopherol is an antioxidant. BHA stands for butylated hydro butylated hydroxyanisole. anisole, BHA, and this one means butylated hydroxytoluene. Right. So these are the antioxidants that are used in the fish processing industry to prevent oxidation of fish oil. All right, that will be it for this video. If you did gain value, which I know you did, make sure to subscribe to that channel. It helps the channel a lot. All right, for those of you that don't understand what I did in the chemistry of the beginning of the oxidation reaction, I'm going to link a video in the description. Make sure you watch that video. Also subscribe to that channel. God bless you as you do so. See you in the next video.